Okay, in chapter 10, it's been all about quadratic equations, and but in the last section here, 10.6, we're going to look at quadratic inequalities. Now, of course, a quadratic equation is an equation in the form ax squared plus bx plus c equals 0. We should know that by now. But a quadratic inequality then would be, instead of this being an equal sign, it's going to be a less than, a greater than, a less than or equal to, or a greater than or equal to sign. Okay, now there's various ways that you can solve a quadratic inequality. I'm going to have us focus on solving a quadratic inequality by using test values and then what's called a sign chart here. So let's take a look at some examples. Problem 24. Use the table to solve the inequality x squared plus x greater than or equal to 2. We'll write the answer under the table using interval notation. Okay. So the first thing that you want to do is you want to find what's called the critical numbers, all right? And this table that I'm going to build over here is going to revolve around these critical numbers. Now, the term critical numbers isn't really a term that you have to know at this point, but basically it just simply means that you're going to find some key numbers to represent on the number line, then that's going to split this table into its various sections. First thing that you want to do is get all the terms onto the left. Okay, and then you're going to call the left side anything you want. I always just call it y. So you're going to say y equal x squared plus x minus 2, and then you're going to set y equal to 0. And we're going to solve this temporarily as if it were an equation. Okay, now I don't have an equation, I get an inequality, but I'm going to temporarily solve this as an equation. Now, with a quadratic equation, of course, we always want to think factoring first. X squared plus x minus 2 will factor nicely as x plus 2 times x minus 1. And when you set the factors equal to 0, you should get x equals negative 2 or x equal 1. Okay, now these two numbers are called critical numbers. And I'm going to place them above this table here on the number line in order, and that's going to split the number line into 3 sections. I'm going to be splitting the real number line into 3 intervals. So in this first section, I'm representing all the numbers that are less than negative 2. Okay, so here's what that would look like using interval notation, all the numbers less than negative 2. The middle section is representing all the numbers that are between negative 2 and 1. And then the right section is representing all the numbers that are bigger than 1. Okay. Now, the intervals, more specifically, are going to be open intervals in the table, parentheses everywhere. I'll comment on that once we've got the table all done. Okay. But at this point, once we have our intervals formed, we're going to select some test values here. Okay, I'm going to choose any number I want in each one of these 3 groups. And then I'm going to plug that number in for x to find a corresponding value of y. All right, so like in the first group here, I need to pick a number. It can be any number I want, just it has to be less than negative 2 though. Okay, so like for example, if x is negative 5, negative 5 squared is 25, minus 5 is 20, minus 2 is 18. So the y value would be 18. Okay, now all I really care about in the chart is if the value of y is a positive or a negative number. 18 is a positive number, so I'll write positive there. And now move on. And so the first column is done. Now I'll move on to the next one. I need to pick a number between negative 2 and 1. 0 is usually a good number if you're able to use it. Sometimes we can't use it, but if I let x be 0 here, I can see immediately that y is negative 2. So that's a negative number. I'll write negative there for the second column. And then in the last column, I need to select a number that is bigger than 1. 4, for example, is bigger than 1. So if I let x be 4, plug that in here. 4 squared is 16, plus 4 is 20, minus 2 is 18. 18 is a positive number. Okay, so now that my chart is complete, I'm going to take a look and see if I'm going to use the positives or the negative conclusion. How I'm going to figure that out is I'm going to look back at the inequality here, and I've got an expression that is greater than or equal to 0. Okay, numbers that are greater than 0 are positive numbers. So I'm going to want the positive conclusions, their intervals, to be represented. So my answer is going to be anything less than -2 and anything bigger than 1. Okay? And the only additional thing that I would be doing here is, now this is not a strictly greater than sign, this is a greater than or equal to. So I want to make sure that I'm including -2 and including 1. If this were a strictly greater than sign, I would not do that, and I would just leave it in parentheses form by those two numbers. Okay. So any number that is less than or equal to -2 or greater than or equal to 1 is going to make this original inequality be a true statement. Anything between -2 and 1 means that it would be false. We sometimes call this a true-false chart instead of a positive-negative chart. It's the same idea, though. So like if I were to let x be 0, and plug that in the original, I'd be saying that 0 is greater than or equal to 2. But 0 is not greater than or equal to 2, right? That'd be false. So any number that would be between this, these two in this interval would produce something that's false, therefore not going to be represented in my answer. Okay, now a couple things about the table. First of all, I mentioned that I'm using open intervals everywhere. Okay, that's just in the table. Now, in your answer, you may have to include the number if it's greater than or equal to or less than or equal to. But in the table here, I don't have that. I've got parentheses everywhere. Remember what we mean by a bracket. A bracket means that you're including the number. So when I'm choosing a number, I can choose any number I want. It's got to be in that group. Now, I don't want to choose the critical number itself, because I already know what happens when x is -2 or x is 1, y is 0. Okay, so a value of 0 is not a positive or a negative number, so I wouldn't be able to conclude positive or negative if I were to select -2 or 1. Okay, so choose any number you want, just don't choose the critical numbers is the bottom line there. Okay, now another thing that I would add to that is to say, when you're choosing numbers, of course, try to choose nice numbers. Like in this first interval, I choose any number I want. It's got to be less than -2. So like I could choose -43 if I wanted. That'd be fine. The only problem is that now I got to do the calculation with -43. Okay, now I'd still get a positive y value, so my conclusion would be the same. It's just you've made the problem more difficult than what it needs to be. So try to choose nice numbers, ones that ideally you can do mental math calculations and not have to run to a calculator type deal. Let's take a look at problem 25 next. Okay, use the table to solve the inequality 2x squared less than 5x plus 3. Well, I'm going to start by getting all the terms onto the left, and then I'll call the left side y and set y to be equal to 0. 2x squared minus 5x minus 3 equals 0. That's going to factor nicely as 2x plus 1 times x minus 3. So x equal -1/2 and x equal 3. That would be my two critical numbers. And I would be positioning those two critical numbers on the number line right above this table here. And that's going to split the table into three sections for me. The first group is any number that is less than -1/2. The middle group is any number that is between -1/2 and 3. And then the last group is any number that is bigger than 3. Okay, so now I'm ready to choose my test values here. So in the first group, I need a number that is less than -1/2. And by the way, of course, make sure that you're selecting a number that is actually in the group. Okay, like I see more than I should where a student selects a number that's not even in the group. Okay, like in this problem here, they'll be using x equal 3 or something like that. Like I don't know what they're doing. 3 is not in this interval. Okay. So -1 is less than -1/2, and if x is -1, Negative 1 squared is 1, times 2 is 2, plus 5 is 7, minus 3 is 4. 4 is a positive number, so I'll write positive. Okay, in the middle interval, I need a number between negative 1/2 and 3. If we use 0 for x, y would be negative 3. So I'll write negative there. And then in the last group, I need a number bigger than 3. If I use 4 for x, plug that in. 4 squared is 16, times 2 is 32, minus 20 is 12, minus 3 is 9, and 9 is a positive number there. Okay, so now my chart is done, and I need to decide if I'm going to use the positives or the negatives. Well, let's take a look at this line here. So I have an expression that is less than 0. Okay, numbers that are less than 0 are negative numbers, and so I'm going to want the middle column to be represented in my answer. Now, I would just simply write the interval down there. This is a strictly less than sign, right? So now if it were less than or equal to, the only additional thing that I would do in my answer is to put brackets there. But this is a strictly less than, so I'd want parentheses there at both ends. Okay.